elementary hote to there are many kinds of relationships. First, we'll be focusing on relations. What are relations in math and how do we comprehend it? We'll be trying to look at the graphical perspective as well. First is a one-to-one relation. What is a one-to-one relation? For example, if I tell you y is equals to 2x plus 3, again, without graphical aid, I cannot teach you functions. I cannot teach you even relations. What kind of a graph will you expect for y is equals to 2x plus 3? Straight line with a gradient as 2 and y-intercept as 3, right? This is my x and this is my y. So you will be getting a straight line with y-intercept as 3 and a positive gradient. We are not looking at the values much, but we are trying to understand something else. So what basically happens for every unique value of x, I will get a unique value of y. I'll show it to you even on the graph. See this. Have a look at the graph. Now, if I have y is equals to 2x plus 3, for every, what is my value of x over here at this point, the point that I'm pointing at, 0.38. And what is the value of my y? I will call my x my input and I will call y my output. So at every different point, at every different instant, you can see both the values are changing. For every different input, I am getting a different output. Is that right? So this is called a one-to-one relationship. What is this called? A one-to-one relationship. Okay? Where every unique input has a unique output. Then comes many-to-one relationship. And the example that we'll be doing in our syllabus are two. I'll be focusing on one for the instance, which is quadratic. Obviously, I'm taking very easy examples to help you understand. This is x, this is y, and I have a graph like this, which is y is equals to x square. If I have a graph like this, now what basically happens on this kind of a graph, if I have y is equals to x squared, what do you see in this? When I plug in a positive 2 over here, what is my output for positive 2? 4, very good. What about negative 2? When I plug in negative 2, what is my output? Again, positive 4. So for even for multiple different inputs, I can get the same output, and this is called a many. For many inputs, you can get one output. This specifically is a 2-to-1 function. It is a subcategory of many-to-one relation. Right now, I'll not be calling it a function. I'll be just calling it a relation for the time being. And now I have one-to-many relation, the example of which can be x is equals to y square. Yeah, y square is equals to x. Now, what kind of a graph will we get? For this one, we will get this is x and this is y. Now, what basically happens in this kind of a graph, we'll get this kind of a shape. For example, if I plug in x as 9, I will get two possible values of y. One will be plus 3 and one will be minus 3, because y will be obtained by square rooting x. And you can see it even on the graph over here. If I write y square is equals to x, again you can see, okay, for one input I can get two different outputs. Okay? This is called a one-to-many relation. Now, what is a function? A function is basically a mathematical relation in which every input has a defined output. Now, what do I mean by defined output? A defined output means the output should be single. I should not get multiple outputs. The output should be a numerical value. If I'm getting a numerical value that I can quantize in real numbers. ठीक है ना? Generally हम उसको function कहते हैं. Pro complex is different thing. So square root के अंदर I must not get a negative value inside the square root. Getting this or not? I must not get a 0 as a denominator because that becomes infinity and that is undefined. I must not get multiple outputs. Is this clear? So that is why a function is a mathematical relation in which every input has a defined output. That is what is called a function. So in the first two, can I say the first two examples that I have written over here, y is 2x plus 3. Instead of using the variable y, I can say fx it is a function of x, which is 2x plus 3. Now, what operations are happening on x? You need to be careful with this. What operations are happening on x? Whenever you plug in any value of x over here, what operations do you do on that? For example, if I tell you f of 3, if I am asking. So 2 times 3 plus 3. So be careful with the operations. If I ask you the sequence of operations, you will tell me that the input multiplies by 2 and then 3 is added and then I get my output. Is that right? Be careful with these operations because students generally have trouble with function transformations who are not clear about these operations in the sequence of operations. Is this clear? So these are the two operations and they are happening in this sequence on every input in this function. Does this make sense? And what about this one? Y is equals to x squared. If I call it gx, g of x is x squared. Now what is happening to the input? Input is squared. Is that right? So these are the operations that are happening. Be clear with the operations. Be clear with the sequence of operations. Okay? Any confusions till this point? This is how we do or understand a function. Now let's talk about domain and range. What is domain and what is range? Domain is the allowed input. How do we write it down? For example, same function fx is 2x plus 3. If I'm not specifying the domain or if I'm not writing it down, that means I want it to be for all real values of x. And what do I mean by real values of x? From negative infinity to positive infinity, I can plug in anything. Have a look at this graph. If I tell it y is equals to 2x plus 3 or fx is 2x plus 3. So it is, if no matter how much I zoom out the graph, it is giving me all possible outputs for all possible inputs. Is this clear? So it is, the domain is from negative infinity to positive infinity for all real values of x. But what if I want to specify the domain? Now the domain can be specified in different ways. I'll tell you how to specify the domain. One way is this, that x is an element of real number. This way I can tell you that x can take any value from negative infinity to positive infinity. Another way of specifying the domain is if I tell you x is an element of real number, but x cannot be equal to 5. This is another way of specifying that domain. I'm telling you x can take any values from negative infinity to positive infinity, but it cannot be 5. Is this clear? This is another way of specifying the domain. Another way is if I'm telling you x can take values from negative 3 to 1. Now x can take values in between negative 3 and 1. I'll give you an example of this as well. In this SMOS, if we write negative 3 and 1. So what does it do? Does it give me infinite graphs now? It gives me limited graphs. I'm only allowing these inputs from negative 3 to 1. And it is only giving me possible outputs on these inputs from negative 3 till positive 1. Is this clear or not? This is another way of specifying the domain. The domain can also be specified this way: x is less than 2 or x is greater than equal to 5. This is also called split domain. X can either be less than 2 or it can be greater than or equal to 5. That means it cannot take the values between 2 and 5. So this is another way of specifying domains. So either ways, we are focusing on input. These are the allowed inputs in any particular function. That is what is called the domain. Is this clear? Now, what is a range? A range is the possible output. What do I mean by that? Same function lenge with different domains. So for the first domain that I took over here, x is an element of real number. Now I told you x can take any values between negative infinity to. So what about the possible outputs? What about the values of y? The graph stretches in y direction from negative infinity to positive infinity. So the range of this with this particular domain will be written as fx is an element of real number. I can get all values. A real number means negative infinity to positive infinity. Every number is a real number. Until unless you get a negative inside a square root, it is a real number. 2 is a real number. 2.000001 is a real number. 3.152 is a real number. Every value from negative infinity to positive infinity is a real number. Now, what about the next one? If I told you x is an element of real number, but it cannot be 5. If you would have plugged in 5 with this, what would have been your output? Why? If you would have plugged it in, I know it is not allowed, but if you plug in 5, 13. So how will you write the range for this one? See, for this one, x is an element of real number. This is your range. You will say my outputs are also all real numbers. If I tell you range cannot be seen without looking at the graph, so you will tell me fx is an element of real number, but my output cannot be equal to 13. I will get all possible outputs, but I will not get the output as 13. Is this clear? Why will you not get 13? Because you're not allowing me to plug in 5. Is this clear? Now, what about the next two? Give it a go, try Karosko. What is the range from negative 3 to 1? You cannot tell me without using your graph. These are very easy functions. You are writing it without using the graph, but not recommended. क्योंकि फिर आगे वाले में मुश्किल होती है. If I tell you negative 3, early brackets negative 3 and positive 1. So, now what are the possible outputs? What is the smallest output that I am getting? Negative 3. And what is the biggest output I'm getting? 5. So what will be my range for this one? I'll say fx is between negative 3 and 5. Now what about this one? X is less than 2. I know it's a straight line graph. If I would have plugged in 2 over here, I would have got 7. For values less than 2, I will say that my function will be less than 7. And for greater than equal to 5, I will say my function will be greater than or equal to 13. These are different ways of writing down ranges. Range cannot be written without looking at the graph. If you are unaware of graphical sketches, you will not be able to specify ranges clearly. Is this clear?